Hello and welcome to the second film in our Wall series. In it, we look at the various demands that are placed on walls. A wall must be able to bear its own weight. What does that mean? A structural element that can bear its own weight is one that can remain stable and in place without assistance. In the case of a wall, this simply means that it does not fall down on its own without any external influence. The wall you can see here is in danger of collapsing because it's too narrow for its length and there is no tied-in wall at 90 degrees, a shear or bracing wall to support it. As you will already know if you've ever tried to build a house of cards, a single card cannot stand on its own. So, every wall must be able to bear its own weight. Once this requirement has been met, comes the question of whether or not the wall is to be part of the load-bearing structure of a building. Walls are divided into load-bearing and non-load-bearing structures. Load-bearing walls absorb loads from roofs and floors and transfer them into the ground. Seen in geometrical terms, these loads are transferred towards the center of the earth according to the principle of gravity. For this reason, they're called vertical loads. Even in this building, vertical loads are transferred towards the center of the earth. Horizontal loads form a counterpart to vertical loads. This image shows Klingenberg Dam and the reservoir that supplies Dresden with drinking water. The dam wall has to be very strong to be able to withstand the lateral pressure from the water backed up behind it. The term lateral pressure indicates that the loads act horizontally on the wall. The lateral loads acting on a building are generally caused either by wind or by earth pressure. Irrespective of its load-bearing function, a wall may be required to prevent the transmission of sound from one space to another. In this halls of residence at Saxony State Music School, the walls are designed to reduce transmission of the noise made by practicing musicians to the adjacent bedrooms. In addition to the structural stability described above, therefore, walls may also be required to provide sound insulation. Some walls are able to react to changes in room temperature. In doing so, they help determine how comfortable a room feels, whether the temperature in them is perceived as positive. Solid walls, such as brick walls for example, radiate the heat or cold that is stored in them. This explains why cellars stay cool in summer and why the wall next to a fireplace may feel pleasantly warm. Lighter weight walls, such as timber stud walls, do not react well to temperature fluctuations because they are unable to store heat or cold. Most walls also need to be resilient. Some walls, the walls of protective rooms for example, have to be practically indestructible. After all, we wouldn't want serious criminals being held temporarily in the cells in our Chemnitz police station to be able to escape through a hole in the wall. And remember that walls should also be beautiful. They form a major part of our built environment, so they should be as attractive as possible in order to create an architectural feel-good factor. This photograph shows the vehicle workshop at the Leipzig Municipal Environment and Waste Department, which we built almost 20 years ago. Even buildings like these, though they may sound inherently dirty and noisy, are work and therefore living spaces and deserve to be well designed. Summary. All walls need to be stable and to be able to bear their own weight. However, walls are termed load-bearing only if they are capable of taking vertical and horizontal loads and transferring them to the ground. Walls may also need to meet other requirements, including noise protection and room climate considerations. Our Walls series continues with film number 3, in which we deal with the materials used to build load-bearing walls.